So you are able to see the slides full screen, correct?
Yeah.
Okay. So again, we come back to our pyramid from the first week of class. We talked about the levels of organization. And so the first week of class, we learned about that pyramid. And then the week after that, we did the chemistry level with the atoms and the molecules. And then last week, we put some of those molecules together and made a cell. And then this week, we're going to take those cells, put those cells together, and learn about tissues. And then for the rest of the semester, we'll be taking multiple tissues, putting them together, and learning about organ systems. And that will essentially take you through the end of this semester and all of 2086. 2086 is essentially just the organ system that we don't cover in 2085. So remember that a tissue is a collection of cells that all have the same purpose. It's basically a whole bunch of identical cells that are together that are going to do one thing. And maybe the easiest example to think of in terms of that, without us talking about these tissues yet, is muscle tissue. You can imagine a muscle made up of a whole bunch of cells that when they all contract at the same time, the muscle is going to act as one unit. And if you have a whole bunch of muscle cells contracting at the same time, you're going to be much stronger than if you had one single cell that's trying to lift a weight. So we have 4 general types of tissue, and we're going to talk very in depth about these 4 types of tissue. That is what today's lecture is. But those are epithelial, connective, nervous, and muscular tissue. All other tissues are subtypes of one of these 4. And so we're going to have some of these little flowchart or diagram type things. If this helps you to see the connection, that might be helpful to you. Generally, the information we have on these diagrams is also in word form, and we'll talk about it as we go. But we see that there's a tissue, and then there are 4 types of tissue, and then you can already imagine that this is going to branch out from that with multiple types of epithelial, multiple types of connective, nervous, and muscle tissue. And so these are just some basic examples of what these 4 types of tissue are. And so nervous tissue makes up our brain, our spinal cord, and our nerves. We're going to have at least 2 different lectures specifically on nervous tissue and the nervous system. Muscle tissue, there are 3 different types of muscle that we'll learn about today. 2 of them are kind of self-explanatory. One of them is definitely not. We have skeletal muscle, which is the muscle that you think of when you think of muscle. So when you talk about your bicep or your traps or your calf, something like that, that is skeletal muscle. We also have cardiac muscle, which even if you've never heard of it before, you immediately know what that is. That's the muscle in your heart that causes your heart to pump. And then we have smooth muscle, which you may or may not be familiar with at all. So smooth muscle is muscle that generally forms circles. And so if you can think of something in your body that can change shape and make force, and it's a circle, it's going to be smooth muscle. And the example on this diagram that it's pointing at is the stomach. And so we know that the stomach kind of squeezes and churns our food to help us digest it. And it's able to do that because there's smooth muscle that goes around the outside of it. And when that smooth muscle in the circle shape contracts, that circle gets smaller. And if the circle gets smaller, the stomach is going to get smaller. Now, smooth muscle is in a lot of places, not just the stomach. There's also a whole lot of it in the intestines. That's what moves the food through our intestines. It controls the size of our blood vessels. If we want to raise our blood pressure, we can make our blood vessels smaller. Think about a hose. If you put the same amount of water through a hose that's wide open on the end, you get kind of a low pressure flow. But as soon as you put a nozzle on it, or you put your finger over the end to make the same amount of water come out a smaller hole, all of a sudden the pressure goes up. That's what smooth muscle is going to do in our blood vessels. We have epithelial tissue, which you may or probably aren't all that familiar with. This is something we're going to spend a lot of time talking about. This is the first type of tissue we'll talk in depth about. But it is going to line surfaces. Both the outside surface, like our skin is mostly epithelial tissue, but it's also going to line the inside of our body. Think about inside of our chest. There's open space there. And if you have open space, whether it is outside or inside of our body, it is going to be lined by epithelial tissue. And finally, there is connective tissue. The name connective tissue is descriptive for some of the types of things that are in connective tissue, like bone and tendon, which obviously connect multiple things together. But there are other things included in connective tissue, like fat and even blood, that are considered connective tissue that don't seemingly connect things together. But we'll talk about all of those when we get to them. So like I said, actually before I start, are there any questions about tissue and in general before we start talking more in depth? All right. So our first one we're going to talk about in depth is epithelial tissue. And we said epithelial tissues are tissues that line our body, either inside or outside. And epithelial, there's lots of different types of epithelial tissues, but the names are just very descriptive. And so every epithelial tissue is going to have two words in its name. One of them is going to describe how many layers of cells are in that tissue, and the other word is going to describe the shape of those cells. And specifically, it is the shape of the topmost layer of cells. In the diagram on this slide that we're going to look at, we see that all of the cells in each box are the same shape. That is not always the case. But when we talk about the skin, I think that's next week, we'll see that as you get deeper in the skin, the cells are more rounded, but as you get up to the top, they're flat. And so the name that we give the epithelial tissue applies specifically to the shape of the cells on the top or outermost layer. It does not matter what the shape of the cells underneath are. And so the easiest way to describe these are the number of layers of cells. The question is there one layer or is there more than one layer? If there is one layer, like we see on the leftmost column, we say that it is a simple epithelium. So epithelium is the noun term for epithelial tissue. If there is more than one layer, that is called a stratified epithelium. And that is the second column here. This little extra column for the third, the pseudostratified, is confusing. When you first look at that, superficially, it looks like there are multiple layers of cells. But when you look at it more in depth, you see that actually every single one of these cells touches this layer at the bottom. So this is the bottom, this is whatever is below this epithelial tissue. But notice that every single one of these cells touches it. And so in reality, there's actually only one layer. And so it's simple, but because it looks like it's stratified, we give it its own name. And we call it pseudo-stratified, and so kind of stratified. But there's only one type of that. Coming back to the simple and stratified, we then give a second word to the name based on the shape of the outermost layer. If the outermost layer of cells is flat, we say it is squamous. Think squamous or squat. So if you squat, you get very short, right? And so this in the top, this box here in the top left is a simple squamous epithelium. It's simple because there's only one layer, and it's squamous because that layer, which by default is the uppermost layer, is flat. To the right of that, we have a stratified squamous epithelium. We have multiple layers, and the outermost layer is flat, and so it is stratified squamous. Coming down a row, we have cuboidal cells. Now these don't have to be cube shaped. They can be cube shaped, but they can also be spherical. They don't have to be perfect cubes. They don't have to be perfect spheres, but generally these are the same size in all dimensions. If they're the same size in all dimensions, we say they're cuboidal. And so here we have a simple cuboidal epithelium where there is one layer of cuboidal cells. And then next to that, we have a stratified cuboidal epithelium where we have two layers of cuboidal cells. The third possible shape is columnar. So they look like columns. And so we see the simple columnar epithelium is a single layer of tall, skinny cells. Now, we see here they've put microvilli on them. One of the places that we're going to learn as a location of simple columnar epithelia is in the intestines. Simple columnar epithelia do not have to have microvilli. They usually do, but they don't have to have them. That's not part of the definition. Next to that, we have the stratified columnar. And usually, here we see that there are two layers of columnar cells. But that's not what they're usually going to look like. When we start looking at microscope slides of these, usually we're going to have something like cuboidal cells and then columnar cells on top. So does everyone understand the naming system that we use to name epithelial tissues? The first word is it simple or stratified? And the second word is squamous, cuboidal, or columnar. And then there's the one oddball of pseudostratified. So here we've taken those and we have started to branch out our diagram. And so with epithelial tissues, we said they could be simple or stratified. And with simple, it could be squamous, cuboidal, columnar, or pseudostratified. For the stratified, we had stratified squamous, stratified cuboidal, and there's also transitional, which we'll talk about in I think a slide or two. And you might have noticed we've actually broken the stratified squamous apart into keratinized and non-keratinized. Keratin is a protection protein. You're going to find that on your skin. Non-keratinized is not as protective, and so it's going to be in places like your mouth where you don't need as much protection. You'll see and you'll learn more about keratinized versus non-keratinized when you do the tissues lab. So here we see a table showing our different types of epithelia. And so you need to know the function and a location of each type of epithelium. So simple squamous epithelium, if something is a simple epithelium, it's one layer thick. And so without exception, a simple epithelium is going to allow things to pass across it. If you have multiple layers of cells, it's going to be much more difficult to get something through from one side to the other. A single layer of cells is designed to allow something across it. Simple squamous, the prototypical place that we find simple squamous epithelia are in the lungs. And in the lungs, we have gases crossing from our blood out into the air. We were taking oxygen from the air into our blood, and we're taking carbon dioxide from our blood and putting it into the air. Simple cuboidal is going to be found in glands, in ducts, as well as the kidney. These are primarily for secretion. So secretion is the opposite of absorption. So secretion is putting something outside of the body. But a lot of times, or like I said, it's usually for secretion, but it can also be for absorption. Simple columnar is more specific. It is always used for absorption. And we said an example of that is in the digestive tract, like our intestine. But it's also found in a few other places, including in our airway. That's the bronchi that are listed here. Pseudostratified are primarily for making mucus, and so this almost exclusively in our upper airway. Then we get down to the stratified epithelia. Stratified squamous is for protection. Stratified squamous is for protection. And so the question is, how much protection do we need? If we need a lot of protection, like on the outside of our skin, we're going to have keratinized stratified squamous. And if we don't need the keratin, we are going to have non-keratinized, like in the mouth. Stratified cuboidal, like with the simple cuboidal, can be found in glands, particularly sweat glands and salivary glands. It is for secretion. It's also for protection. If you're taking notes, I would suggest putting secretion in here also, along with protective. Stratified columnar is only in a few places. Really, the only example where you could come up. So I just saw the question. I'll get back to that in a second. The textbook definition of stratified columnar is in the male, specifically the male urethra. It is a lot of protection, but also some secretion. And then there is the transitional epithelium. It's called transitional epithelium because the shape of the cells will actually change. They transition from cuboidal to squamous when it stretches. And the best place to remember where this is in the bladder. The bladder needs to expand as it fills with urine. And so when it is not stretched, the cells are cuboidal, like we see in the picture here. But imagine taking those cells and stretching them to make the bladder bigger. At that point, they're actually going to look like a stratified squamous epithelium. But because they bounce back and forth, we don't label them one or the other. We make them their own thing, the transitional epithelium. So the question was, can pseudostratified only be columnar? And the answer is yes. You won't see a pseudostratified squamous or cuboidal. So this is basically what we just talked about. It's in a slightly different form. If this helps you to study, you can use it for that. But it's the same material we just talked about. The glands in our body are made up of epithelia, or epithelial tissue. That is a definition. Glands are made out of epithelial tissue. Glands are things that make something and then secrete it. In some cases, it could be outside of the body. Other times, it may be into other parts of the body. We have two types of glands, depending on where the secretions go. We have endocrine glands and we have exocrine glands. Remember that the prefix endo always means in. So in this case, whatever this gland is making is going to stay inside of the body. And if it stays inside the body, it's most likely going to be secreted into the bloodstream. An example of an endocrine gland is the thyroid gland. exocrine glands secrete something out of the body. Think exit, exo. A great example of this is a sweat gland that obviously goes outside of the body. But things that secrete into the digestive system, something that secretes the acid into your stomach or secretes digestive fluids into your intestines, are also exocrine glands. At first glance, inside of your digestive tract may seem like it is inside of your body, but it's actually not. The lining of your digestive tract is actually the outside world. Think about it. If you eat something, it goes through your mouth, which is the outside world, down your throat, which is connected to the outside world, into your stomach, into your intestines, and out your anus. It is all one open tract going the whole way through. All we do is pinch off in different places along that. And so the lining of your digestive tract is actually the outside of your body. And so things that secrete in your digestive tract are considered exocrine glands. So that is epithelial tissue. Any questions about epithelial tissue? Okay. So the next we'll talk about is connective tissue. Connective tissue is made out of two ingredients. Here we have cells and what we call extracellular matrix. Epithelial tissue is almost completely cells. It is cells packed in as close together as they can be. Connective tissue is going to have cells that are spaced more apart. In actuality, the only reason the cells are there is to make the extracellular matrix. The extracellular matrix is why connective tissue exists. In the extracellular matrix is everything between the cells. And we're going to learn that there are a number of things that can be, but just remember the extracellular matrix is everything between the cells. Earlier I said that blood was actually considered a connective tissue. And so for blood, the extracellular matrix is the plasma. So it is a liquid, a fluid. Bone is also connective tissue, and its extracellular matrix is hard. So you can't make a definition of what extracellular matrix looks like. You just have to remember whatever is between the cells in connective tissue. The extracellular matrix is made up of two things itself. There is ground substance and protein fibers. Now, I'm going to start with the protein fibers. Ground substance isn't as complicated as it seems. So, like I said, we'll start with the protein. So these fibers, they look like fibers. They look like sticks or spaghetti strands. Come in three flavors. We have collagen, reticular fibers, and elastic fibers. We'll see those three different types. And so imagine you take a whole bunch of sticks and you throw them into a tub of water. You're going to have stuff filling the gaps between those sticks. That is the ground substance, and it is basically clear jello. It is thick water. All it does is it fills in the gaps between the fibers that make up the extracellular matrix. So here we see the diagram showing the types of connective tissue. We have three primary types. There's fibrous, cartilage, and bone, and we'll talk about each of these as we go. So the one, I think it's the only one we're not going to see a picture of, but you will see a picture of it in the lab, is areolar tissue. And so this slide is looking at types of loose fibrous connective tissue. And what determines whether it is loose or dense is how tightly compact everything is. And when you look at a slide, when you see a picture, it's going to be obvious. You're going to look at something and say, well, clearly everything is very densely packed. That is a dense fibrous connective tissue. Whereas other ones, you're going to look at and say, well, everything's really spread out. There's a lot of empty space here that is clearly loose. So that includes areolar tissue, which we'll leave for another day when you learn about the lab. There's adipose tissue and reticular tissue. So this is adipose tissue. Adipose tissue is fat tissue. When you look at this, you look at that and it makes it seem like there's a lot of empty space here. When you look at the slide on the right, you see mostly white. And if you look at a microscope slide and you see white, that means there's nothing there. And so it could be easy to make the assumption, well, there never was anything there. But if we look at the diagram or the drawing on the left, we see it's not white, it's yellow. That is the fat stored in the adipose tissue. When we make a microscope slide, we take basically a razor blade and we shave a layer off to put it on a microscope slide. If you take something that's filled with fat or oil and you slice it, all that fat's just going to run out and go away. That's why on the microscope slide on the right, we see nothing. So this is adipose tissue. This is remember, a loose connective tissue. You look at that, there's a lot of empty space there, even if it means that it is empty space because the fat is gone. There's a lot of empty space. You look at it and there's just not a whole lot going on. So it's a loose connective tissue. This doesn't have very much extracellular matrix. The cells are actually fairly close together. We know the obvious function of fat for energy storage, right? That's why if we eat too many cookies, we get fat. Our body is assuming incorrectly that at some point in the future we're going to have a cookie shortage and we're going to need that fat. It also provides insulation. Think about a whale, right? A whale has blubber. It can also be protective. So that's not shown on this slide, but fat is in some locations primarily as a protective or cushioning tissue. The best examples of that are behind the eyeball. And so because we are taking this online, you won't be able to do the eyeball dissection in lab. But one of the things that really jumps out at you when you see an eyeball is how much fat there is. You don't see any in the front because the front of the eyeball is the functional part. But if you take an eyeball out of the socket, everything back here is covered in a thick layer of fat. There's also a layer of fat around our kidneys. Our kidneys are not protected very well. Most of our very important sensitive organs are up here in our chest, inside of our rib cage. The ribs are there to protect them. Our kidneys, though, even though they are just as important, they're not up in our rib cage. You've probably heard of somebody getting punched in the kidneys or a kidney shot, right? They're fairly exposed in the back. And so because they don't have bone protecting them, there's a layer of fat around them. Now, if you get hit hard there, that fat's not going to do much. But the small little blows, every time you sit down in a chair or you lean back kind of hard, that fat's going to absorb that force rather than your kidneys absorbing it. Next is reticular tissue. Reticular tissue has these very dark little fibers in it. So when you're looking at this microscope slide, there are a few things that you're seeing. You see three primary colors. There's kind of a white, there's a kind of medium purple, and then there's what looks like black lines. The white is basically open space. This is where that ground substance or that clear jello would be. There's quite a bit of it here. And so that's why reticular tissue is called a loose connective tissue. The purple that you're seeing are nuclei of cells. And then the black lines, if you look at them, they look like little black worms. Those are the reticular fibers. So reticular tissue has reticular fibers. Here on this table, we see a good example of where reticular fibers are in the lymph nodes and the spleen. Reticular tissue is not very common in the body, so most likely on an exam, the correct answer would be lymph node and or spleen. We only have two types of dense connective tissue. We have dense regular connective tissue, and we have dense irregular connective tissue. I'm now realizing the word regular in the slide title here should not be there. Cross that out. Types of dense connective tissue. There is regular and irregular. There's only one type of dense regular. And so here we see those two types of dense connective tissue. The one on the top is regular. The one on the bottom is irregular. What we're referring to with those terms is the direction that the fibers go. In regular connective tissue, dense regular connective tissue, all the fibers run in the same direction. In dense irregular tissue, notice the fibers go in all different directions. Now that's for a good reason. These types of tissue are located in different areas. So if we go back, we'd see here that regular tissue provides strength going in one direction. Irregular tissue is able to stretch in many different directions. Regular tissue stretches really, really well in one direction. If you try to stretch it the other way, though, it's not going to work very well and it's going to break. Irregular tissue can stretch in all directions, but it can't go all that far. And so a dense regular is found in things like tendons and ligaments. They are designed to stretch in one direction, and they need to stretch that one direction very, very well without breaking. But you probably, if you are an athlete or you watch sports, you know athletes tear their tendons and ligaments very, very often. Because when you're doing extreme movements, putting a lot of force on your joints, something happens and you put the force on the tendon or ligament in the wrong direction, the direction it's not supposed to stretch, and rather than stretching, they tear. Irregular is found underneath the skin. Everywhere you have skin, you have a small layer of dense irregular tissue. Skin can stretch, and it can stretch in every direction, but you can't stretch it all that far, right? You can stretch it a little bit, but not very far. Otherwise, it's going to tear. But you can put it in any direction. So here's a review question for you. Which of the types of connective tissue is in tendons and ligaments? Yes, this is dense regular. So we just talked about that. We said tendons and ligaments need to stretch in one direction, and so that is going to be dense regular. Questions about those types of connective tissue before we keep going? Okay. So the other types of connective tissue we have to talk about are cartilage, bone, and blood. So I think, yeah. So this is going to be for reference. We're not going to sit here on this slide in this table and talk about it as we go. So cartilage is a connective tissue that is supportive. It serves many of the same functions as bone. It serves to hold things in place. but it is flexible, whereas bone is not flexible. The cells that make up cartilage, or cells that make cartilage, are called chondrocytes. So these chondrocytes are the cells that are going to make the proteins in the extracellular matrix that is going to make up cartilage. Something unique about cartilage is that it has no blood vessels, meaning if you break it or damage it, it's going to heal very, very slowly. So up here in your nose, if you feel it, right up kind of here, there's a bump, and you can feel that it transitions. There's something below that and above it. And the stuff below it is flexible. The stuff above it is hard. So up above is bone, down below is cartilage. The bone actually has a lot of blood flow. If you were to break your nose up here, it would heal fairly fast. If you break your arm, that heals in a month or two. But if you badly break the tip of your nose, it's going to take months and months and months to heal and be as strong as it was to begin with. So we have 3 types of cartilage, and they each have a slightly different function. The first is hyaline cartilage. Hyaline cartilage is clear, it looks like glass, and it has flexibility, but not too much flexibility. And the best example of where you find hyaline cartilage is on the tip of your nose. It is clearly flexible, but you can't exactly bend it around and touch the tip of your nose to your cheek. Another place we find this is in our ribs. Our ribs are bone, but where they connect to our sternum is hyaline cartilage. So that if we get a force applied to our chest, or even when we breathe, there's some flexibility there, allowing those bones, the inflexible bones, to move. Fibrocartilage is very, very strong. It only bends a little bit. Fibrocartilage is found primarily in 2 locations. One of them is called the pubic symphysis, which we'll learn about in the skeletal lab. But it is where the 2 halves of your pubic or your pelvis come together. And so if you imagine you have a pelvis, and right in the front there's bones that come together. Between those bones is fibrocartilage. We don't want our pelvis to be flopping all over the place. We need it to be strong. But we do put some fairly strong forces on our pelvis. Like if we jump up or we jump off a step. All that force goes right up your leg onto your pelvis. So that allows it to flex a little bit to kind of absorb some of that shock so that we don't break bones. The other place we find fibrocartilage is in between the vertebrae in our neck, in our back. And so those vertebrae can actually compress a little bit. Just like with our pelvis, if we put a lot of force on our vertebrae, it's going to provide a little bit of shock absorption. So I'm sure you've heard of people who say they've slipped a disc. In between our vertebrae, we have discs of fibrocartilage. And so what happens is that fibrocartilage gets out of place, which causes a lot of problems. Number 1, we have a lot of nerves running in and around our vertebrae. And so that cartilage, if it's out of place, can pinch a nerve. But also, if it's out of place, that means there's no cartilage between those vertebrae. And so then you get bone on bone. And bone on bone is never supposed to happen. If you have bone on bone, it's going to be very, very painful. The third type of cartilage is elastic cartilage. This is something that can hold up its own weight, and it provides some structure, but is designed to be very, very flexible. And the best example of that is your ears. Your ears stand up on their own. But if you put any force on them at all, they're just fold right over. We have slides on this, we have pictures of slides on this slide, but this is not really important for the lecture. You'll see these slides in the tissues lab. Next is bone. Bone. Yes, go ahead.
I'm sorry. So for the three types of cartilage, between the hyaline, fibrocartilage, and then elastic.
Yep.
The elastic is the most flexible, and then between hyaline and the fibrocartilage, which one is the least forgiving?
Fibrocartilage is the stiffest. It's a fibrocartilage bends the least, elastic cartilage bends the most, and hyaline cartilage is in the middle.
Okay, thank you.
You're welcome. Other questions? So next is bone. Bone tissue itself is not a correct term. We don't call it that. We call it osseous tissue. Osseous is a technical term for bone. We'll learn a lot more about osseous tissue. We have an entire lecture on the skeletal system, and the lecture for the skeletal system is almost all physiology. The lecture is not going to be about this is the name of this bone, this is the name of that bone, this is that bone. That's the lab. And so for the lecture for the skeletal system, we'll learn all about the cells and the structure of bone. But bone, the cells that make bone are called osteocytes. Remember, the cells that make cartilage were chondrocytes. The cells that make bone are called osteocytes. And around them is collagen and minerals. So the osteocytes are actually going to secrete, they're going to make collagen, which is just protein. That's a type of fiber. And then over time, it is going to absorb minerals to make it hard. Think of like petrified wood. So all the calcium and the phosphorus are going to come into that collagen and make it hard. We have two primary types of bone. We have spongy bone and compact bone. The bone that you are imagining, that I guarantee that you are thinking of in your head right now, is compact bone. Spongy bone actually looks like a sponge. So again, that's all we're going to talk about bone right now. You'll get much more in depth later. So blood, again, remember, blood is a connective tissue. It has a few different types of cells. There are white blood cells and red blood cells. We're not going to go more in depth than that. You'll learn all about the blood in 2086 next semester. But you know we have red blood cells and white blood cells. You know that red blood cells carry oxygen and white blood cells are our immune system. But don't forget that the plasma around those cells is the extracellular matrix of blood, which is why it is considered a connective tissue. Questions about connective tissue? Okay. What time is it? Let's take a break. Let's come back in 5 minutes. So my clock says 6:49. We'll come back at 6:55. So did anybody do anything fun this weekend? Nobody did anything fun.
Ready for the exam? First exam?
Well, that's fun, right? I honestly don't remember how well you did, and you don't say because everybody's gonna hear. But hopefully it worked out and it was worth it for you.
Yes, it was. Thank you.
Does anyone have thoughts on what you hope Santa Fe does next semester in the fall with classes? Do you want to be in person, or do you want to continue to be online?
I think I would like, I would prefer to have things in person. I think I'm more of like a visual learner where if it's in front of me, it'll make a lot more sense. So like being able to go to an open lab or see diagrams and models and stuff, that would be helpful. But it
Yeah.
is convenient just like, sitting at home, being
Yeah.
able to log into class.
Yeah, I think the vast majority of students, especially for this class, are better served with in person. The question is, is it safe? And so I honestly, I'm glad it's not my call. I can tell you that much.
I like in person as well, but I thought it's pretty cool to be able to have dinner during lecture and not have everyone else in the classroom hearing me munch because I chew and drink pretty loud.
Yeah, so the classes I always teach are always evening because this is not my primary job. And so technically, we're not supposed to have food in class, but I always allow people to eat. I had one class that they actually would order pizza every week.
What? Oh my god, that is so cool. Are you teaching the second part in the fall?
No, so I teach this class, and spring and fall and spring, I only teach it just completely online without live lecture. And I normally only teach it in person in the summer, which is what this is now. And then in the fall and spring, I also teach a couple of biotech courses in Alachua.
Gotcha, okay. Oh, only 26 professors specifically? Because honestly, the best one I've had.
That's so you were kind of breaking up. I couldn't hear you.
Oh, do you recommend any 2086 professors?
So the adjuncts come in and out all the time. I don't really, I can't suggest against any of them. The two primary, who used to be the two primary people, one of them retired. That was Samia Williams. The other one that's still here is Rhonda Fellheim. Dr. Fellheim runs her class. The way she presents things is pretty similar, I feel, to how I present things, but the way she structures her exams and the points in her class are a little bit different. And so you can decide for yourself whether that is a good thing or a bad thing. The other person that teaches a lot is Caswell, Dr. I think it's Caswell? Something like that. I've never met him. I don't know anything about him. Really, the only person I can speak on at this point is Dr. Fellheim, and I would say you certainly cannot go wrong with Dr. Fellheim. I would not suggest against her.
Yeah, I really like the way you teach, so I'm curious what you thought.
Yeah, so it was interesting, just by chance. It used to be she and Samia Williams were the two full-time A&P people, and Dr. Fellheim ran her course in class, similar to me, but Dr. Williams set up her course structurally more like me. So I was kind of in the middle of the two. But I don't know the other people well enough. I know Dr. Blackburn has been around. She's an adjunct, but she teaches quite a bit. She's been around quite a bit, and I generally hear good things about her. And I've met her in person, but I've never seen her teach. Okay, so it is 6:55, and so we will pick up where we left off. And so we were about to talk about nervous tissue. And nervous tissue is another one where we're going to have it's 3 full lectures to talk about it. And so we are not going to go very in-depth today. And so nervous tissue is made up of two types of tissue, or two types of cells. We have neurons and neuroglia. I think in the cell lab, you saw a picture of a neuron, and you saw that it had these little appendages coming off. And the purpose was to connect to each other. So when you picture the nervous system, and you've seen these pictures with cells with all these little branches coming off, you are thinking of neurons. They are the fundamental or the functional cells of the nervous tissue. They carry those signals, the electrical signals from one place to another. But there's also a whole bunch of what we call neuroglia that are in nervous tissue. The neuroglia cells are cells who are there to help the neurons do their job. And the way I think about this is, if you have an elite athlete, they are the ones who actually perform, right? But they have all of these other people who support them along the way. They have trainers, they have nutritionists, they have what's the word I'm looking for? They have people who get their contracts. I'm drawing a complete blank, but you know what I'm talking about. So all these, what was it?
Sponsors.
Say sponsors. So they have sponsors, but what's
Like managers?
Not managers. Come on, we got like 10 people here. Somebody's got to think of the word. The person they hire to negotiate their contract for them. Agent, yes, agent. Thank you, yes. So an athlete or a celebrity or anybody who has a very, very important job, or even a boss, a CEO of a company, they have all these people that help them do their job so they can focus on the part that only they can do. So the neuroglia help the neurons to carry these signals. They're going to protect the neurons. They're going to wrap around them and protect them from the outside world. But we're also going to see in the nervous system, it's very, very important for the environment around those neurons to be correct. If we have the wrong environment around them, it's not going to work. And that is going to be the concentration of sodium and potassium, but that is not something you need to know currently. Eventually, that's going to be very, very important. So then we move on to muscles. And we have the three types of muscle tissue that we already saw. We have skeletal muscle, cardiac, and smooth. So I think, yeah. So this table is for studying, and we'll talk about them on this slide where we can see them. So skeletal muscle makes up most of the muscle in our body. This is the muscle that is connected to bone. Now, we don't necessarily think of our muscles as being connected to bone, but they are. So like our bicep and the muscles in our forearm and in our finger, all they're really doing is they're pulling our bones around. They're connected to bone, they're moving our bones. When we look at the slide here, to the left of it, and we'll go through this again when you watch the lab video, but there are a couple important, very, very important, actually 3 very important things to see here. Number one is that the slides are huge. Usually, when we look at a slide, we see little cells. Now, the 3 that are on here aren't the best to look at and see individual cells. But usually, you look at it under this microscope and you see little cells all over the place. With the skeletal muscle here on the top, you can see very, very distinct lines of red, right? Don't overthink it. If you see a band of red, that is a skeletal muscle cell. And they extend off both sides of the slide. That's because they are huge. Also, when you look at cells, purple dots are going to be nuclei. Now, I said that this was one muscle cell, but I see 1, 2, 3, 4, 5, 6, a whole bunch of nuclei for that one cell. Skeletal muscle cells actually have a whole bunch of nuclei because they actually started as as multiple cells that fused together to make one. And when they continue to have multiple nuclei, because they're so big, each nucleus can only control a certain volume or space or amount of cell. So to control a very large cell, we need multiple control centers. The other thing that is specific, what's the word I'm looking? Maybe is key to skeletal muscle are what we call striations. And the striations aren't all that prominent in this slide, actually, but I think the one in the lab is much easier to see. Striations, if you look at it, as we go along, there are vertical bars. There is light, dark, light, dark, light, dark, light, dark. And if you see that, we call that striations. And striations mean it is either skeletal muscle or cardiac muscle. Smooth muscle, which is the one in the middle, and we'll talk about next, has no striations. So skeletal muscle is connected to the bone. They're very large cells. They have multiple nuclei, and they are striated. Also, something that the table points out is that skeletal muscle is voluntary, meaning that we can control when it contracts. I can say, fist, punch me in the head, and it comes up and it hits me in the head. I don't know if you could hear that, but I actually did hit myself in the head. So I can make my skeletal muscle do whatever I want. Now, just because it is voluntary doesn't mean it can't function on its own. A lot of times skeletal muscle works without us thinking about it. If I get up and I walk to the other side of the room, I'm not going to think about moving my legs. In reality, if I think about how do I move my legs to make myself walk, I'm probably going to fall flat on my face. Skeletal muscle can be voluntary or involuntary. Smooth muscle is only involuntary, meaning we cannot purposely make it contract. We said smooth muscle was found in places like our digestive tract, in the stomach, in intestines, and also our blood vessels. I can't say stomach contract and have it contract. It just doesn't work that way. It is involuntary. Smooth muscle cells are small cells. They are not the smallest cell. I think when people fill out the cell lab, there's some version out there. I think it's on Quizlet where people look up the questions and they find the answers. And I think Quizlet must say that the smallest cells are smooth muscle cells, which is not correct. So internet is not always your friend. But smooth muscle cells are much, much smaller than skeletal muscle cells. There's only one nucleus per cell, and they have no striations. The third type of muscle is cardiac muscle. This is only found in the heart. It is striated. They are fairly small cells again. One nucleus per cell. What is unique about cardiac muscle, they have intercalated discs. So intercalated discs, I'm looking at the slide. So again, they didn't pick the best picture here, but we can see one here. So on a microscope slide, an intercalated disc looks like a bit of a dark line separating two cells. And what an intercalated disc allows is it allows one cell to communicate directly with the cell next to it. Usually, for a cell to communicate with the next cell, it has to send something, it has to go outside and then come back. An intercalated disk actually allows free flow of contents of one cell over to the other. And that's going to be very important because when we talk about muscle, when we learn more about muscle, we're going to learn that muscle contracts due to electric impulses. Now, you've probably seen things where you can put an electrode on yourself and the muscle twitches, right? If you put electricity on a muscle, it contracts. For skeletal muscle and smooth muscle, we generally want the muscle cells to contract at the same time, but them contracting milliseconds apart from each other doesn't really make much difference. For cardiac muscle, though, we need all of those cells to contract at once. If they don't contract all at once, the blood is not going to pump properly. And so the intercalated disc allows the electrical signal to move from one cell to the next, to the next, to the next, to the next, at the speed of electricity, so that all of the cells contract at the same exact time. So which types of our muscle is voluntary? Yes. Skeletal muscle was the voluntary muscle. Which one had intercalated discs?
Cardiac.
Yep, and what was the purpose of the intercalated disc?
To separate the cells.
So that separates the cells and what?
Conduct electricity so that they can all contract at the same time.
Correct. So it connects the cells together. It keeps one from separate from the other, but it has tiny little pores that are going to allow that electricity to move directly from one to the other. Bigger things like proteins are not going to be able to get through there, but electricity can move right through it. So that kind of brings us to cell junctions. And so we said intercalated disc holds two cells together and allows things to pass through it very, very easily, like electricity. We have three primary types of cell-to-cell junctions. So this is the glue that holds the cells together. First, in the top left here, we have tight junctions. In this, to me, when I look at that, to me it looks like taking two pieces of fabric and sewing it together. We have these proteins that go all the way through and pinch the two cells together. What you're looking at, these two pink layers, are the plasma membranes of two cells. And so we're sewing those two plasma membranes together, essentially. In that case, those plasma membranes actually touch each other. It is impossible for anything to move in between these cells. Meaning, if we have cells that have these tight junctions, and something needs to get from one side of those cells to the other, it has to move through the cell. And so a lot of times, these tight junctions are going to be used in places where we want the cells to filter things, where we want something to have to go through a cell to get to the outside, so that the things that can't get through the cell, we don't lose. But the things that can diffuse through, can diffuse through. Next, we have gap junctions. Those are the ones on the right. This would be a intercalated disc, would be a type of a gap junction. You can see that there's actually basically a pore, a hole that runs from one side to the other. And I think of this as being like a rivet. If you had a rivet that was empty in the middle, you take two things, put a rivet through them, hold them together. Those two things are kind of independent. They can kind of wiggle back and forth a little bit, but they can't leave each other. And so this is going to leave a gap between cells, which is why it's called a gap junction. But it's also going to leave this pore, allowing direct communication from one to another. The third type is called a desmosome or an anchoring junction. Those are two terms for the same thing. So in these situations, the cells are held together by proteins. And so what we see is one cell puts out a protein, another cell puts out a different protein, and if they come together and they touch, they link together, and they're holding those cells together. Now the benefit of this is if you want to let go, all you have to do is let go. This is more of a temporary hold, whereas the others are permanent. There's no way to undo a tight junction or a gap junction. I don't need you to worry about all of the details in this diagram here. Just look at the picture and see that the cells put out proteins and the proteins stick to each other, and the cells themselves are not actually connected to each other. So this link takes you to a website that has a bunch of microscope slides where you can look at these types of tissue. This is probably more useful for you in terms of the lab, because for the lab here, you're going to be expected on the lab exam, if I show you a slide of a type of tissue, you need to be able to tell me what type of tissue that is. And so if you go to this website, you can do the same thing by just doing like a Google image search. Just type in the type of tissue and then look at all the pictures and make sure that you see what is common about all of these things, so that when I see one of them, I can say, hey, that is a stratified squamous epithelium. And I think this is our last slide already. So what type of tissue covers inner and outer surfaces and forms glands?
Okay.
Yes, that is epithelial tissue. So the last thing I want to do before we leave is I want to, now I can't make you put your slides away because I have no idea if you're looking at slides or not. But without me changing the slide, I want to go through as many of the types of tissue as we can think of. And so, for epithelial tissue, we named them based off of two characteristics. What were those two characteristics that we used to name epithelial tissues?
Simple and stratified?
Yes. So somebody also said shape and number. And so you were talking about simple and stratified. That is a number of layers. So simple means one layer. Stratified means more than one layer. For the shape, what were our different shapes?
Squamous is one.
Squamous,
Columnar,
columnar,
cuboidal,
and cuboidal. So cuboidal is cube-shaped or round. Columnar is column-shaped. What shape is squamous?
Squished. Flat.
Squished or flat. Yeah. We had a couple other kind of oddball epithelial tissues. What were they? Pseudostratified. It looks like it's stratified, but it's actually simple. And what was the other one? It was a type of stratified tissue. It changes shape, actually.
Transitional.
Yep, transitional. So, where would you find simple squamous epithelia?
Like linings of intestines and stuff.
So simple squamous. Here's
lung,
lung, yeah. So it's in a few other places, but the answer is answer to that is always going to be lung.
Okay, simple.
What about what type of tissue makes up your skin?
Keratin epithelium.
Keratinized. You're missing a couple words in there.
Oh god, what is it?
Shape and number. Don't forget shape and number. You might. You probably got to look this one up at this point. So the skin is for protection, right? So if it's for protection, how many layers do we want?
Has to be stratified.
Yeah, it's going to be stratified. Now that the harder question is, what shape is that?
Squamous?
No,
Squamous.
squamous. So your skin is keratinized, stratified squamous epithelium.
I said it wrong. Squamous, not squamous.
What else? What type of tissue lines your intestines? So, what is the function of the intestine? Absorption. So if we want to absorb something, are we going to have one layer or are we going to have multiple layers? Single. If we're going to absorb, we want something to easily be able to pass across. So we're only going to have a single layer. So it is going to be simple. Is simple columnar. So intestine is simple columnar epithelium. Okay. So what about connective tissue? What were some types of connective tissue that we learned about?
Blood.
Blood. What else? Bone.
Yeah.
Cartilage. Yep. And then we had kind of the more vague ones at the beginning. What were they? We had loose and dense connective tissues. What were the types of loose connective tissue?
You have regular connective tissue and irregular connective tissue.
Yeah, so we have regular and irregular dense connective tissue. What's the primary difference between the irregular and irregular dense connective tissue?
The fibers on the regular connective tissue. Oh my god. I know the irregular one looks kind of messy, so that's how I'm going to remember it.
Right.
Supports movement in one direction only.
Right. So the regular is not messy looking because everything is running in the same direction, because they need to stretch in one direction. The irregular looks messy because the fibers move in all the different directions so that it can stretch in all the different directions. And someone pointed out that this is a type of fibrous connective tissue. We have loose and dense fibrous connective tissues. Those were the dense fibrous connective tissues. What were the loose fibrous connective tissues?
Like skin.
There were three of them I think we talked about. Reticular was one. Fat, adipose tissue is the other, And then the third one, the one we didn't talk about in lecture much, is the areolar connective tissue. Where is reticular tissue found? It's not in many places.
Is this the one that's behind the eye and then like around the kidneys?
That's adipose tissue.
Oh,
This is in just two very specific places.
The lymph nodes and spleen.
Yeah, lymph nodes and spleen. Most people don't even think of the spleen as existing. There are two types of cells in nervous tissue. Oh, actually, we didn't finish the connective tissue. We had three types of cartilage. What were the three types of cartilage? Hyaline is one. Elastic is two.
there's like a fiber one.
Fibrocartilage. Yeah. So hyaline, elastic, and fibro. Which one is the most flexible?
Elastic.
Elastic. Which one is the least flexible? Fibro. So hyaline is in the middle. Where do you find elastic cartilage?
Ears.
In your ear. Where is the hyaline?
Nose.
In your nose. And I'm just doing this just in case you don't know where your ear and your nose are. And where do you find the fibro cartilage?
Vertebrae.
In the vertebrae and in the pelvis. Yeah.
Yeah.
I think I don't know. I might have misheard somebody. I thought I heard somebody say ribs. The ribs are actually hyaline cartilage. Going back to the nervous tissue. What are the two types of cells in nervous tissue? Neuroglia and neurons. So neurons, remember, are they are the most important cells, and the neuroglia are there to help them along. We had three types of muscle tissue. What were the three types of muscle tissue?
Cardiac, skeletal, and smooth.
Cardiac, skeletal, and smooth. What are the characteristics of skeletal muscle? Striations.
They're really big.
They're really
Multinucleated.
really big, multiple nuclei. And there was one other. I'm trying to think. I don't know how I can give a clue without giving it away. Voluntary, yeah. And so skeletal muscle is voluntary. Where do we find skeletal muscle?
Your muscles, like your biceps.
Yeah. What you think of as your muscles is skeletal muscle. Where is cardiac muscle?
Your heart.
Your heart. What are the characteristics of cardiac muscle?
Involuntary.
Involuntary.
Intercalated disc.
I didn't hear that.
Intercalated disc.
They have intercalated discs. What else?
Striated.
They're striated. How many nuclei per cell? One. I think that's everything we talked about for cardiac. What about smooth muscle? Where do you find smooth muscle?
Hollow organs.
Yeah, organs, blood vessels, things like that. What are the characteristics of smooth muscle?
It's much smaller than skeletal.
Small cells.
Involuntary.
Involuntary.
Non-striated.
Non-striated single nuclei. I think that's probably it. I wasn't writing it down. I think we got everything. So that is. Go ahead.
Are all of our blood cells made of smooth muscle? Or not blood cells, blood vessels?
So the blood vessels themselves, they have smooth muscle in them. And so imagine, okay, yeah, this will work. Imagine you have like a garden hose. And so a garden hose is kind of flexible, right? Imagine taking your finger and going like this around that garden hose and pinching it off like that. That's the smooth muscle around the blood vessel that can pinch it off. Inside of there is actually what's called endothelial cells, which isn't really a type of tissue that we even talked about. But they're cells, they're not muscle cells. And so basically you have kind of the wall of the blood vessel, and then you have muscle in the wall that allows it to contract and expand. Other questions? Nothing? But it's only 7:30. You all get lots of fishing time today. You might have to fish for your goldfish depending on where you live, but at least you're going fishing. That's better than not fishing.
What kind of fish do you catch in your area?
I'm primarily a bass fisherman.
Ah, okay.
Anything else before we go? So with this lecture, you're now ready to do the tissues lab, which should be lab 3. Speak now, forever hold your peace. You can always email me later, but I won't be available until a little after sunset, so that's about 9.
On the exam, are we going to have cell slides where we see the slide and have to identify based on the picture?
On the lab exam, definitely yes. On the lecture exam, definitely no.
Okay.
Okay? So if I don't hear from you between now and then, I will see you next Tuesday. Have a good week.
Thank you.
Good night.
Good night.